Welcome to the Explainer. You know those boxes you see tucked away in offices and server closets? The ones with that crazy web of cables and all those little blinking lights? Well, what does a network switch actually do? Today, we're going to pull back the curtain on this super important piece of hardware. We're going to turn that blinking box into the intelligent brain of a network that you can finally wrap your head around.
I mean, it really does seem like magic, doesn't it? But it's all pure technology. And the answer, more often than not, is hiding inside that unassuming box, humming away quietly in a closet somewhere. That box is a network switch, and believe me, it is the absolute heart of all your local connectivity.
All right, so let's start at square one. To really get why a switch is so essential, we have to look at its most basic job on what we call a local area network, or a LAN. At its very core, a switch is just a central connection point. A good way to think of it is like a digital roundabout for all the hardware in your office, or maybe even your home. Every single PC, printer, and server plugs right into it, and that's what lets them all form one single cohesive network.
But here's where it gets really smart. You see, the switch represents a huge leap in intelligence. The older tech, a thing called a hub, was basically like a town crier. It would just shout every single piece of data to every single device connected to it. Talk about noisy and insanely inefficient. A switch, on the other hand, is much more like a clever mail sorter. It knows exactly which device a piece of data is meant for and sends it only there. And the result? A way faster and much less congested network.
So the really crucial thing to remember is that a switch does way more than just connect cables. It's actively managing the traffic, and it does this by forwarding these little data packets, which are called Ethernet frames. To figure out where to send them, it identifies each device using a unique hardware ID called a MAC address. This whole intelligent delivery system is what makes our modern local networks so incredibly fast and efficient. Now, that intelligence we've been talking about, well, it can operate at different levels. Not all switches think the same way, so let's get into the layers of how they actually make their decisions. Now, to understand this, we need to quickly touch on something called the OSI model. Don't worry, we're not going to get bogged down in the technical weeds here. Just think of it as a standard rulebook that divides all network communication into 7 layers. Switches mostly do their work at layer 2, and sometimes the smarter ones work at layer 3. And trust me, understanding that difference is the key to choosing the right gear. So here's the main difference in a nutshell. A layer 2 switch uses those physical MAC addresses we just talked about. It's built for super fast communication within a single local network, like sorting mail inside one big office building. But a layer 3 switch, it's even smarter. It can also use IP addresses, which lets it route traffic between different networks, a job that used to only be done by a totally separate device called a router. This choice really impacts everything, from cost to complexity, and it determines how well your network can handle things like video calls between different departments. Okay, so now that we know how these switches think, let's take a look at their physical forms, and just as important, how much control we actually have over them. Because the hardware you pick has a huge impact on what your network can do. First up, let's talk about expandability. A fixed switch is pretty simple. It has a set number of ports, and that's it. It's perfect for a small network that isn't really going to change. A modular switch, though, is a whole different ballgame. It's built for growth. You can actually add more ports, extra power supplies, or more cooling fans as your needs get bigger. It's really all about planning for the future. And next is the level of control you have. An unmanaged switch is basically the definition of plug and play. You just plug it in, and it works. End of story. It's perfect for a home network or a really small office. But a managed switch, well, that is a different beast entirely. It gives a network administrator total granular control to configure settings, monitor all the traffic, and set up advanced security. It's really the difference between a simple power strip and a fully programmable smart home control panel. You're also going to hear the terms standalone and stackable thrown around. A standalone switch is exactly what it sounds like. You have to manage each one individually. Stackable switches, though, are pretty cool. They can be linked together, which lets an administrator configure a whole bunch of them as if they were one giant switch. And let me tell you, that is a massive time saver in bigger networks. Okay, we have covered the job, the logic, and the physical hardware. So for the final piece of the puzzle, let's pop the hood and look at the software, the operating system that's running this whole show. Yeah, that's right. These aren't just simple electronic boxes. A modern managed switch is actually a pretty powerful computer, and it runs a very sophisticated operating system. And for a huge company like Cisco,
Their switches primarily run on one of two major OS families. So Cisco has two real powerhouse operating systems. On one side, you've got Cisco iOS. That's the long-standing, super reliable workhorse that runs on their Catalyst switches, the kind you'll find in most big corporate offices and on college campuses. On the other side, you've got NXOS. That's a more modern OS designed for the crazy high-performance demands of massive data centers, and it runs on their Nexus switches. Just think of it as your reliable daily driver versus a Formula One race car. So, the next time you see that blinking box, you won't just see a simple connector. You'll see a high-speed decision maker, a digital traffic cop, and the very brain of the entire local network. And now you actually know how that brain works, from its physical body to its operating system, which kind of makes you wonder, is your network's brain ready for an upgrade?